So we have acid, alkali, and salt question. This is an important topic related to your paper 4, as well as you will find the questions in paper 6 as well. Ethanoic acid is a weak acid and hydrochloric acid is a strong acid. Both ethanoic acid and hydrochloric acid dissociate. Define the term acid. Acids are proton donors. The chemical equation shows the dissociation of a strong acid of hydrochloric acid. We have to dissociate ethanoic acid. So even ethanoic acid, methanoic acid, propanoic acid is there. That's very good if you put a reversible reaction, because for weak acids, because strong acids ionize completely, that's why we draw the arrow in one direction. But weak acids ionize partially. So if we have ethanoic acid, methanoic acid, propanoic acid, or acids are proton donor, but because these are weak acids, so dissociate partially. So it will form CH3, COO negative and H positive. If it was propanoic acid, like example C2H5COOH, so again this H will be lost because the weak acid, they will lose their proton, so it will form C2H5COO negative and H will be positive. A student does experiment to show hydrochloric acid is a strong acid and ethanoic acid is a weak acid. The student adds an excess of a hydrochloric acid and an excess of ethanoic acid to a sample of calcium carbonate. Only the identity of acid is changed between the experiment. All other conditions kept same. State 2 observation, which would show that hydrochloric acid is a strong acid. So rapid effervescence, like rapid effervescence, you can say that is right. Rapid effervescence, phase bubbles, and the change in the mass will be greater change in the mass, like faster, not greater, because the concentration is same. So faster or quick change in the mass. Yeah, solid disappear quickly. That's right. The next state 3 conditions which must be kept same for ensure a fair test. What are the 3 conditions which should kept same? So we should take same temperature. Uh, Concentration is the right term rather than just volume and concentration. Either mention one of them. Same temperature should be there. Same pressure. This is actually same size of the lumps should be there. Like as I mentioned, same size of the lump. Size of, if you mention volume, uh, it's fine, but mention concentration or a volume, any one will be considered. Then you have to say about the size as well, size of the lumps. The next question is related to the moles. You can annotate on the screen and work out the moles. Use the screen annotation, read the question and work out the moles. And I will explain after that. So the first part, calculate the number of the moles. You have 50 cm cube and 2 mole per dm cube. So moles equals concentration into volume. So it was 2 and multiplied by volume was 50 divided by 1000. So this gives the moles. And then you need the moles of magnesium. Can determine the moles of magnesium carbonate. You took a ratio that is 2 is to 1 or 1 is to 2. If you write magnesium carbonate first, then it will be 1 is to 2. So if we have hydrochloric acid 0.1, so this will be X. We cross multiply. We got 0.05 moles here. I think this was 0.05 as it will be half. Uh, then the relative molecular mass of magnesium carbonate, magnesium is 24 plus carbon is 12 and oxygen is 16 multiplied by 3 makes 84. And then we need the concentration, calculate the mass of magnesium carbonate. So if we need the mass in gram, we have the formula moles equal mass in gram divided by molar mass. So how many moles were there? 0.05 moles. Mass in gram is unknown and the molar mass was it was 84. So 84 is divided, other side multiplied. The final answer we got 4.2 grams. So for moles question, the first by formula, then by ratio, and then again by formula. This was finding the molecular mass. It's like using a periodic table can be done. A student prepare crystals of magnesium chloride by adding an excess of a magnesium carbonate to 50 cm cube of 2 mole per hydrochloric acid. The student filter the mixture and rinse the residue. Why does the student add excess of a magnesium carbonate? So so acid like hydrochloric acid completely used up in the reaction. Why does the student rinse the residue? Look, what actually happened? We have a hydrochloric acid, HCl is there. To remove, whenever we rinse, we say we remove impurity, but we'll say to remove soluble impurities, impurities which can dissolve. So remove impurities is fine, but add the term soluble whenever washing is done. So if a hydrochloric acid is there, if a hydrochloric acid is there and a magnesium carbonate is added in excess, so unreacted magnesium carbonate will be left here. And the solution, because the hydrochloric acid is completely used up, so it will be magnesium chloride. And then we will use filtration. When we use a filtration, the unreacted magnesium carbonate will left on the filter paper. And what passes through is a solution of a magnesium chloride. And we rinse with this residue, we rinse with the water. Describe how the student would obtain a pure crystals from the filtrate. So you have to mention the points of filtration, like we will heat and concentrate the solution till the point of crystallization. Then we will cool the solution and then we will filter again. But this time we'll not wash because these are the soluble crystals. So we'll filter and then we'll dry with the tissue paper. So soluble salts cannot be washed. If you wash the soluble salt, then it will dissolve and you will not get the salt. Silver chloride is insoluble salt, which is made by precipitation. Barium chloride and a suitable aqueous. So what is the term meant by term precipitate? Precipitate, it's actually the solid which is formed by mixture of two solutions. When two solutions are mixed with each other, the solid which is formed is called the precipitate. So the term precipitate is actually refers to a solid form by a mixture of the two solutions. Then we want to prepare silver chloride like AgCl. One of the salt was barium chloride. What is the other salt we need? Because we want silver, so silver, and it should be a soluble, so all nitrates are soluble, so it will be silver nitrate. And as a result, the product will be silver chloride plus barium nitrate. So then we have to complete the equation. Like the salt, we use silver nitrate. So AgNO3. As a result, it will produce AgCl plus barium nitrate. Then equation must be balanced. So we put 2. Silver is balanced. We put 2. Silver is also chlorine. Rest all of them are balanced. So this is a balanced equation for reaction between silver nitrate and barium chloride. Insoluble salts can be prepared, can be made by precipitation reaction. Like when we mix the two solutions, a precipitate form, we call them as a student mix the solutions of some salts. The results the student obtain are shown. All sodium salts are soluble in water. Use only results from the table. Answer the following question. An insoluble salt of cobalt. Which is an insoluble salt of cobalt? Which salt? Look, this is cobalt nitrate. No, cobalt nitrate is soluble, but this is cobalt nitrate and this is sodium carbonate. So when cobalt, like when we mix them together, cobalt nitrate, sodium carbonate plus cobalt nitrate, as a result, it will form a purple precipitate. So when it form a purple precipitate, so these purple precipitates are due to cobalt carbonate. So you have to mention it's a cobalt 2 carbonate. Insoluble yellow lead salt. So yellow lead salt means this one. How this salt is formed? It is formed by lead nitrate and sodium iodide. So if you have lead nitrate combined with sodium iodide, it will produce lead to iodide. So lead to iodide here, lead to iodide, and you're supposed to say the name because the question is name. It's fine, like as a right now, it's fine to save the time we are writing formula. But in exam, because it's written name, so you have to name that. Write a chemical equation for a reaction in which silver carbonate is formed. So which one forms silver carbonate? Because this is silver nitrate and this is sodium carbonate. When silver nitrate react with sodium carbonate, it will form silver carbonate. So we want an equation for that. Like if we have AgNO3, silver nitrate reacted with sodium carbonate. As a result, it will produce silver carbonate. But it is important that you write a correct formula for silver carbonate. Silver valency is +1 and a carbonate valency is -2. So silver 1 carbonate, the valency will be Ag2, like formula will be Ag2CO3 plus it will produce sodium nitrate, so NaNO3. Then we want to balance, that's why it's of 2 marks. So we have 2 silver here, so if we put 2, silver is balanced. Nitrate is also balanced. Sodium is not balanced, so we put 2. Like now we put 2, nitrate is balanced, so rest all of them are balanced. So this is an important part. Like whenever you complete an equation, you should always work out the correct formula, because if formula is correct, then equation can be balanced. If your formula is wrong and you try to balance a wrong equation according to a wrong formula, you will lose both marks. So it's important, first, don't try to balance the equation. First, try to write the correct products. Write an ionic equation for a lead to iodide formation. So how lead to iodide is formed? Because lead to iodide means lead is +2 and iodine is group 7 -1. So lead to iodide will be PbI2. That is what we want. So what are in ionic equation, the ions react to form a compound. So what are the ions? So there's a lead 2 ion and there's iodide ion, but how many should be there? We should have 2. And the state symbol, ions are always aqueous, so AQ, and the lead iodide will be solid. Lead, it can have +3, +4, but you will take as +2 when there is a compound, until unless they mention. But because it's a transition element, that's why it's already mentioned. You can have lead 3 as well. Even lead 4 is also possible. So this Roman number shows the valency of the lead. An aqueous silver nitrate produces a yellow precipitate with both iodide ions and carbonate ion. When testing an unknown solution of iodide, the aqueous silver nitrate is acidified. Explained why aqueous silver nitrate is acid. Why we add acid? Like, because in the question they mentioned that when silver it give a yellow precipitate with iodide, so silver 1 iodide and silver carbonate, both are both will give a yellow press. So whenever we are testing an iodide ion, we always add acidified silver nitrate, not simple silver nitrate. So what is the reason for that adding? So it will remove the acid, because acid can react with carbonate. So it will remove the carbonate ion. So it does not interfere with the result. Otherwise, if you may have iodide ion and some trace of carbonate ion in the solution, so what will happen? Like mostly it is iodide. The solution, mostly it is iodide. And if some trace of a carbonate is there, so whenever we are testing, because when carbonate is there or iodide is there, both cases it will give a yellow PPT. So whenever we are testing for iodide, the first thing what we do, we add acid. What is the reason for adding an acid? Because acid can react with carbonate and it will remove the carbonate. It will give carbon dioxide, water, and the salt will be there. But this carbonate ion will be removed. So, so carbonate ion will be removed when we add an acid. Now, when we add silver nitrate, so if there is a iodide ion, it will give a yellow precipitate only because of iodide. Otherwise, if acid was not added and there might be a trace of carbonate in the mixture, then it will give a yellow precipitate because of carbonate. Is it clear, this one?